Hello everyone, welcome back to interesting session of 10th physics, the chapter electric current. In the previous class we discussed about Kirchhoff's first law. It is also called as a junction law. In this video I would like to teach about Kirchhoff's second law. Look at here, Kirchhoff's second law also called as a loop law. It is also called as a loop law. It also called as a Kirchhoff's voltage law. Kirchhoff's voltage law, it is called in shortcut form KVL. KVL means Kirchhoff's voltage law. To understand Kirchhoff's voltage law or loop law, we must know about sign conventions that are applicable to the Kirchhoff's law. For the better understanding of sign convention, at here I drawn a circuit or loop. So it is a loop or circuit or mesh. It is a mesh. You can call it as a loop. From this loop, look at here. This is A and B and C, D, E, F. So at here there is a battery, a source, the potential difference, voltage V1. This is also another battery, the potential difference V2. And it is a resistor R1, it is a resistor R2 and it is the resistor R3. Now, look at here in this loop, in this circuit, the direction of the current is like this. The direction, the current flows in this direction from positive pole. It is the positive pole of the battery, positive pole to negative pole. So it is the direction of the current. For this battery, this is the direction of the current. So in which way the direction of the current? In this way. Okay, clear. So the direction of the current is in this way. I mean in this direction, from the right side to the left side. Are you clear? Now look at here. First I am going to take the first loop A, B, C, D. A. It is the first loop. Yes or no? In the first loop A, B, C, D, A. It is the first loop. In this first loop, what is my direction in the first loop? This is the A point. I am going from A point to B point. So the loop direction is in this way. Yes or no? So from these two observations, the direction of the current, the direction of the loop direction from A point to B point, I am going in this direction. This is the direction of the loop. From this, look at here. When the direction of loop opposite to the direction of current. Yes or no? The current direction is in this direction and the loop direction from the A to B, the loop direction is in this direction. We are going in this way. Then I value, current value and resistance R values taken as positive. Look at here, dear students. When the direction of the current and the direction of the loop both are opposite each other, then we will take the current I value, the resistance R value as positive because they are both are opposite each other. And the second point at here is, look at here. If the current direction in this way as well as loop direction also in this way, both are same in direction, then it is the taken where as negative. So the direction of loop and direction of current same means it's taken as negative. It's taken as negative. So these are the two sign conventions for current value and resistance value. Then I am going to tell about sign convention for voltage V1 and V2. Okay, look at here. Look at here. When the current goes from positive pole of the battery to the negative pole of the battery, means the direction from the positive to negative, then it is taken as a negative. So at here, from positive to negative means positive to negative, then it is taken as negative. If the direction from negative to positive, then the value taken as positive. It is about another sign convention methods. Look at here. For example, it is the symbol of battery. If the direction goes, the current direction goes from positive to negative, means it is taken as a negative. If it is taken as negative to positive, means it is taken as a positive. So these two are the sign conventions for application of Kirchhoff's second law. Now I would like to teach about Kirchhoff's second law. Let's start the class. Okay guys, this is loop law or Kirchhoff's second law. What is this law states? Look at here. The algebraic sum of increases and decreases voltages across various components of the closed circuit loop must be 0. At here, look at here, the algebraic sum of increases and decreases voltages across different components of the closed circuit or closed loop. So it is a closed loop. In this closed loop, there are number of the components like a battery, like resistors. These are the components, do you know? In this battery, in these components, all values like a voltage values, increasing and decreasing voltage values are must be 0. This is the statement of Kirchhoff's law. Now I am going to apply this Kirchhoff's law in the formula by taking sign conventions. Focus carefully. Look at here. It is a loop. It is also called as a mesh or closed circuit. In this loop, I will take first loop as A, C, D, B, A. So I am taking the first loop, the first part of this loop to apply Kirchhoff's law. So what is the first loop? Applying for loop, I am applying Kirchhoff's law. For loop A, C, DB, A. Are you clear? Now I am applying Kirchhoff's second law to the loop A, C, D, B, A. So this is the loop. Let's start. So dear students, at here my starting point is A. I am starting from the A, going like this, then like this. Yes or no? Look at here, loop direction. I am going through the point A, loop of the point A to the C, from the C to D. The loop direction, how was the loop direction at here? Opposite to the flow of current. This is the flow of current. The current flows in this direction from the right side to left side. Look at here. So this is the direction of the current. What is loop direction? A to C, C to D. So loop direction is in this way. So at here, the loop direction and current direction both are opposite. As we discussed in the previous about sign conventions, when the loop direction and current direction both are opposite, the value is positive. Then what about I2 and R2 values? Yes, plus I2, R2. What about the voltage value? At here, look at here. I am going from positive terminal of the battery to negative terminal of the battery. I am going in this direction from positive to negative. When I am going from the positive to negative, then the value negative, as we discussed in the sign convention. So at here, voltage V2 value is minus. So minus V2. What about the current and resistor values? Plus I2, R2. Next one, it's over. This side is over. CD side is over. Are you clear? I2 and R2 values are positive. Why? Because I2 and R2, the loop direction is in this way, but current direction, I2 direction is current direction is in this way. Both are opposite. That's why I taken I2 R2 value as a positive. Why I taken voltage value as a negative? Because it goes from positive to negative, like this, positive to negative. That's why it is taken as a negative. If I go from negative to positive, means I will take as a positive. Okay. Next one, it's over. Then goes from point D to B. There is no any components. Then B to A, B to A. So my direction is in this way. Say sir, no? From B to A means the direction is in this way. Then what are the values of I1 and R1? The direction of the current and the direction of the loop also same. From the sign conventions, when the direction of the loop and the direction of the current is same, the values are taken as a negative. So at here, I1, R1s are negative. So minus I1, R1, because from the B to A, the loop direction is this in this direction, as well as the current direction also same in direction. That's it is taken as a negative. What about voltage V1? Look at here. I am going from negative to positive. So when we go from negative to positive, the value is positive, then V1 is positive. Look at here. The algebraic sum of algebraic means minus plus values. The algebraic sum of increasing and decreases voltage values, increasing and decrease values of voltage across various components like resistors of a closed loop must be zero. So it is the formula of first loop. It is the value of first loop. I applied Kirchhoff's law in the loop AC dBA. Shall we apply Kirchhoff's law for second one? Yes. Let's tell with me. Okay, now I am applying Kirchhoff's law for loop. Look at here. This side and this side is over. That's why I am taking this side and this side. I mean lower one and middle one. So from this E, F, D, C. E, F, D, C, E. It is the loop. Are you clear? In the first one we completed A, C, D, B. So both are over. In the second one it is not over. So that's why I am taking this one and this one. E, F, D, C, E. So E, F, D, C, E. This is the loop. Tell me, by applying conventional methods to the Kirchhoff's law, tell me. So I started from here. Okay, C, from the point C. So C to E, nothing is there. Then E to F, then E to F. Look at here. What is the current direction? In this direction, means from this side to this side, from the left side to right side. So what is the current flows? I1, I2. What is the resistor? R3. Look at here. The direction of the current and the direction of the loop both are same. Say sir, no? I am going in this direction, means loop direction is in this direction. What about current direction? Current direction also in this direction. Both are same in direction, then we will take it is as negative. So from this, look at here, from this minus I1 R1 into minus I1 plus R1 into sorry. That's why minus I1 I2 plus I2 into R3. This side is over. What about that? What about next? There is no any components. Again from point D to C. Look at here. I am going from the point D to C, means the loop direction is from D to C, right side to left side. So in this direction, the loop direction is in this direction. What is the direction of the current? Current are same in direction. That's why I will take these values as also negative, means minus I2 R2. Then at here voltage minus to plus. Say sir, no? This is the negative pole, this is the positive pole. I am going in this direction. That means from negative to positive, then we will take as a positive. So plus V2. So these all values must be 0. This is 0. This is about application of Kirchhoff's law by using conventional methods to the loop EF DC. Are you clear? Let's do for another loop EF BA without middle loop. So we didn't take middle loop, just we are taking entire outer loop, that is EF DAE. Let's tell with me. Applying for loop, what is the loop name? EF BAE. EF BAE. It is another loop, outer loop EF BAE. Now I am going to apply sign conventions as well as Kirchhoff's law to the loop EF BAE. From this, look at here, I am starting from this point. So as well as in the previous, the current direction and loop direction are same. I am going in this way, so the loop direction is in this way, as well as current also in this way. So both are same in direction, then we will take it as negative value. So minus I1 plus I2 into R3. Are clear? I1 minus I1 plus I2 into R3. So there is no components. Let's go. There is no components from F to B. Then come to the point B to A. From the B to A, the current direction as well as we are going from the B to A means loop direction. This is loop direction, it is a current direction. Both are same. So we will take as a minus values. That's why minus I1 R1. What about voltage value? Minus 2 plus negative 2 positive. When we are going voltage from negative to positive, then the value is positive. That's why positive V1. This is also 0 according to Kirchhoff's law. This is third loop. So we can apply Kirchhoff's law for different loops in different ways. This is today's class about Kirchhoff's law. I hope you understand. If you have any doubts, ask me through the comment section. Thanks for watching. Keep smiling. It's better to read again. It is better to watch 2 more times for the better understanding of this video. Thanks for watching. Don't confuse at all. Keep smiling. Take care in this pandemic situation. Thank you very much.